Most data pipelines break at scale because engineers treat all data as simple, static tables. But in production systems, data generally behaves in two distinct ways: entities that represent current state and streams that preserve events. If you treat them the same way in your pipeline, you risk either silently losing history or ballooning your cloud compute bills. So let's fix that. We are inside Pipeline Builder, and looking at our Intel refinement pipeline, on the far right we have our atomic outputs. Let's look at the operative roster atomic first. This dataset tracks physical human beings. So if an operative status updates from active to on leave or something else, we want to reflect their current state, not append a duplicate row. To set this boundary, we click directly on the operative roster atomic node on our visual graph, and in the properties panel, we will click the configure write mode. By default, outputs write as standard datasets, and we're going to change this to Snapshot replace. In Foundry, this mode requires us to set a primary key, so we will select operative ID. This establishes a strict database contract. When the pipeline runs, it outputs a snapshot transaction, using our primary key to update records and guarantee uniqueness. This keeps our master roster clean and ensures downstream reads remain cheap by avoiding expensive deduplication scans. Now let's look at the opposite pattern: mission logs atomic. So this is our stream. We never want to overwrite a historical mission log. So if an operative is deployed 3 times, we must preserve all 3 entries to maintain our operational audit trail. So we're going to open now the configure write mode again, and here we will select always append rows. Notice that we do not select a primary key here. We want every single row, regardless of duplicate IDs, to stack chronologically on disk. Click undo just so that you can see some of the other advanced options in the dropdown, like changelog or snapshot replace and remove. Those are for complex change, data capture patterns, or soft deletes, which we can cover in a later episode. But for your baseline operational backbone, getting this core snapshot versus append topology right is majority of the battle. So with our transaction semantics configured, you pretty much just go ahead and apply the rules, and afterwards you can deploy to start the build. And then behind the scenes, Foundry translates these configurations into different write operations. For our roster, it performs a snapshot merge based on our primary key. For our logs, it appends new rows while preserving our historical partitions. So by taking the time to architect your transaction types at the schema boundary, you keep downstream applications simple and performant. So the next episode will process these appends incrementally, so we only compute what changed, and that's where the real cost savings begin.